Hello students. In the last video we solved a couple of word problems that involved the Pythagorean theorem. In this video we're going to continue with that and solve some questions that are just slightly harder than those that were in the first video. Once again, what I suggest you do is have a go first and then check your answer. You're going to learn a lot more mathematics by struggling with a few problems than just watching me do it. So turn the video off or pause the video and come back when you've had a go. Okay, welcome back students. Let's see how you went with this one. So the question is, the length of the hypotenuse on an isosceles right-angled triangle is 16 centimeters. What is the length of the other two sides? So this is more of a mathematical application than a practical application. Now the secret here is you have to remember what an isosceles right-angled triangle looks like. And an isosceles triangle has two sides the same length, and it has to contain a right angle. And what that means is the triangle is going to look something like this. The two shorter legs are the same length, and the hypotenuse, the length of the hypotenuse, is 16 centimeters. Now, here's the secret to solving this problem. The fact that it's isosceles means we're not going to write A and B on those two sides because it's isosceles, therefore they must both be the same. So I'm going to write just the letter A on each side. Okay, there's my diagram. Let's go ahead and use Pythagoras and see if we can solve it. So that's C, that's going to be A, and that's going to be B. So once again, we start by writing the Pythagorean theorem. C squared equals A squared plus B squared. In place of C, I'm going to write 16. In place of A, I just write an A. And in place of B, I write an A. Okay, so now we're basically just solving some algebra. We've got to solve that equation for A. Well, if you've done some equation solving in the past, and I'm sure you have, these are like terms. A squared plus A squared just simplifies to 2A squared. Now, how do I solve that equation? Well, I've got two operations. I'm multiplying by 2 and I'm raising to a power. Order of operations in reverse says the first thing we have to do is undo the multiplying. So we divide both sides by 2. And I have A squared equals 16 squared over 2. Now what I'd better do now is work out what 16 squared over 2 is as a number. So I need a fraction. On top, I'm going to put 16 squared. On the bottom, again, check that what I've typed up there matches what I've put there. And that's equal to 128. So let's get rid of that. Once again, I need to undo squaring by taking the square root of both sides. And the square root of 128 is 11.31. And I think I'll probably round it off to like 2 decimal places. So in this case, 11.31, because there's a 3 in the third decimal place, it stays as 11.31. So that's the exact answer. A equals square root of 128 centimeters. And the approximate answer, A equals 11.31 centimeters. By the way, it's a good idea to just have a look and say, yeah, that seems about right. This has to be shorter than that, but not a whole lot shorter. So I think we've got the correct answer. Okay, have a go at the next question, please. Okay, let's see how you went. Okay, the rectangular frame for the wall of a new building is 7.5 meters high and 18 meters long, and it has one diagonal support. If the frame, including the diagonal support, is constructed from steel girders that come in 10-meter lengths, find the cost of the frame if the girders cost $230 each. Okay, let's get a diagram of the rectangular frame. Again, neat freehand is all you have to do here. And I'll put in my diagonal girder like so. And being rectangular, we know that that's a right angle just in there. So that is 7.5 meters. And that is 18 meters. And what we don't know is what the length of that is. So because that's a diagonal support, I'll just call it the letter D. So the question is, how much is this whole thing going to cost to construct? So the first thing I have to do before I can answer that is to work out exactly how long the diagonal strut is. So let's go ahead and do that first. Okay, so that's side C, that's side A, that's side B. And as before, we know that Pythagoras tells us that C squared equals A squared plus B squared. In place of C, I write D. In place of A, 7.5. In place of B, 18. Okay, let's go ahead and work out what 7.5 squared plus 18 squared is. So 7.5 squared plus 18 squared. So D squared equals 380.25. Once again, take the square root of each of those sides, and D is the square root of 380.25. So square root of answer, and that comes out to be exactly 19.5 meters. Okay, that's the first part of the problem solved. We know now how long each of the girders is. Now they come in 10 meter lengths. So we got to work out how many 10 meter lengths we need. And I don't think we can actually use one girder to one length to do two different sides. So pretty much now it's going to be just carefully adding up. So I'm going to need one for the left side and one for the right side, which gives me a total of 2. For the 18 meter length, they come in 10 meter lengths. I'm going to need 2 for that and 2 for that. Total of 4. That's the top and the bottom. And for the 19.5 meter length, I'm also going to need 2, because 2 times 10 is 20. If I add all those together, 2 plus 4 is 6 plus 2 is 8. I'm going to need 8 girders. And at $230 each, I just need to multiply 230 by 8 to get my overall cost. So let me do that using my calculator. 230 times 8, and it's going to cost me $1,840. So summarizing once again, we had to read the question carefully, draw the diagram. Once we had the diagram drawn, we used Pythagoras to find the unknown side length, and then we had to go back and do some additional calculations to work out the cost of the girders. Okay, one more video on applications, which once again is looking at some more challenging questions. So we'll see you back in a few minutes.